Okay, so let's have a little think about how we might deal with finding the median from a group frequency table. So if we remember, the median as an average is your middle value from your piece of data. It's whatever is halfway along all of your list of different pieces of data. Um, Again, as with the mode and range, we're going to run into some problems with our grouped frequency table because we've lost some of the information by putting it into groups. We can work out an estimate for the median, but we're going to come back to that. Instead, for this video, we're going to look at finding the median group, which is the group that contains the middle value. And this process is going to be pretty much the same as when we're finding the median from an ungrouped frequency table. If you remember, what we do is we first of all sum the frequencies. We find out what the total frequency is going to be. So that's 5 plus 7, which is going to give us 12, plus another 12 gets us to 24, and then plus the 9 finally gives us a total of 33. So I'm just going to use this symbol. That's So I'm just going to use this symbol. That's a capital sigma, which means sum of. So I'm going to say the sum of f, which you might also see referred to as n, just for the number of pieces of data that we have. And so we're saying n is 33 here. So having worked out that 33, we need to find where the middle is. And doing that calculation is as follows. Before, when we were working with ungrouped data, typically it was discrete data. So it could only take on integer values or specific fractions. It couldn't be any possible value in between. Here with grouped data, the chances are we're going to be working with continuous values, so they can take any level of accuracy that we like. And with continuous values, all we do, say, now with discrete data, what we would have done to find the middle position is we would have taken, if you remember, the 33 and added 1 and then divided by 2. And that calculation would find to the middle position of that discrete data. So that would be 34 over 2, which would be 17. So the 17th position for the discrete data. But that's specifically for discrete data that we need to make the adjustment, that +1 there, in order to find the proper middle position. When we're talking continuous data, which is what we've got going on in here, it's a little bit simpler. We just do the 33 divided by 2, which in this case, of course, is going to be 16.5, the 16.5th position. That's for continuous data. So that's the calculation we do. That 16.5 is what we wanted. In all fairness, if you get confused and you're not sure which way to around to do it, for your group data, we're going to find that actually both of these are going to get you pretty much the same result anyway. So don't worry about it too much. But nevertheless, that 16.5th position is what we want to count along. We've already been doing this counting already, so we know that this group has the first 5 pieces of data. Then this group adds on another 7 pieces of data, so we get to the 12th piece of data by the end of the group. The next group adds on another 12 pieces of data, so now we've reached the 24th piece of data, which means somewhere between the start of that group, which started just after 12, and the end of the group, which gets to 24, we must have passed position 16.5. So that means somewhere between this 20 and 30 here, we had the median value. And quite simply then, that means that our median group is that 20 to 30, because that's the group that the middle position lies in, the median lies in. In a later video, we'll look at actually working out an estimate for the median itself somewhere within this group. But if you're asked for just the median group, then that's what we're looking for.